Welcome to Wonders of Our Universe Unplugged. We haven't had to travel too far to film today's episode. I've arrived here at Witham Park in Boston in Lincolnshire, which is quite close to where I live, and we're going to use today's episode to investigate some real world science that's happening right outside our front doors every single day, something that we call the quantum leaf. Now, there are lots of deciduous trees here in Witham Park, trees that lose their leaves during the winter time. So we need to take a little walk through the woods here and see if we can find a tree that's still got some leaves on. And I'm going to explain to you exactly what's happening with that leaf. So after quite a lot of walking around Witham Park, I finally managed to find a tree which has some ivy growing up the trunk. Now, this fine specimen of nature behind me is around 40 or 50 years old, or something like that. But right now, just about passing by the planet Venus is a quantum bullet, and it has this ivy's name written on it. Now, it's typical for physics experiments to be conducted in the controlled, clean environment of the laboratory, but it's also important to remember that our beautiful planet is one great big living, breathing science lab, and this wood is no exception. There are wonders of our universe happening here. Every day on our planet, around 16,000 tonnes of new plant life is created, and I find it absolutely astonishing that all life on planet Earth depends on what's going to happen in the next 1/trillionth of a second. Now, when a photon from the sun travels through space and strikes the surface of this ivy leaf behind me, it interacts with the chlorophyll cells that make up the leaf. The photon knocks an electron out of the middle of a chlorophyll cell, and that process creates a tiny packet of energy that we call an exoton. That exoton then travels through the forest of chlorophyll cells that make up the leaf, trying to find its way to the reaction centre, which is at the base of the leaf. When it reaches the reaction centre, it delivers that packet of energy to the leaf and to the tree, and that is what drives the magical biochemical processes that make life on our planet. It's a bit like me trying to find my way out of this wood blindfolded. I'm sure I would bump into a tree or two, and as amusing as that may be, I'm not going to do that today, but I am going to explain how the exoton does it. Now, this blindfolded approach, which we call the random walk, is clearly not very efficient. Yet the exciton manages to deliver almost 100% of its energy to the reaction centre of the leaf. So something else must be going on. The exciton must be doing something far smarter than that random walk. And it is. Now, the exciton isn't simply moving from point A to point B in a straight line. In a very real sense, it's exploring all possible routes simultaneously, and that is what makes the exciton so efficient at delivering its energy to the reaction centre of the leaf, and it strikes at the heart of everything that we find weird and fascinating about the world of quantum mechanics. Now, in recent experiments in the laboratory, scientists have fired laser beams at the cells that make up leaves to try and figure out what is going on with the exciton. And it turns out that the exciton isn't taking this random walk. Something far more strange is going on. It was observed that the photon behaves in a completely different way and obeys the biggest law in quantum mechanics, the Heisenberg uncertainty principle. And this tells us that we can never be truly sure of the fixed position of the exciton when it's making that apparent random walk through the chlorophyll forest of the leaf. It behaves like a magical quantum wave, spreading itself out over the surface of the leaf, taking every possible route at the same time. By interacting in this way, the exciton avoids taking wrong turns in the chlorophyll forest, losing valuable energy as waste heat, ensuring that the plant or tree is fed with the maximum amount of energy possible from that photon. Beautiful quantum mechanics happening in a trillionth of a second, trillions of times per second, literally everywhere on planet Earth. My time at Witham Park here in Boston has come to an end now, so let's make our way back to the car and warm up. It may look bright and sunny here, and we may have been exploring the quantum world of photons and excitons, but it's 2 degrees Celsius on a crisp January afternoon. Definitely time for a coffee. So that is the magic of the quantum leaf, a wonder of our universe happening trillions of times a second, right outside your front door. Photons from the sun travelling through space as quantum waves, striking the surface of a leaf and powering all life on our planet. If you did enjoy this video, please like and subscribe and follow us for similar content, and keep a lookout for our theatre shows which are touring all through the UK throughout 2025. But for now, I'll see you on the next Wonders of Our Universe Unplugged.